Hello and welcome to Education at SSBJ online video tutorials. We were in chapter motion of class 9th. Right in front of us we have three problems here, and these three problems are on the concept of distance, displacement, speed, average speed. Right? So these are important problems. You may expect this in examination. So we'll go ahead with the first question now, and then if time permits in this video, we'll go for the second and third question. Otherwise, we'll take these questions in the next videos. So the first question is, I'm just reading this. A farmer moves along a boundary of a square field. So this is a square field, right? And a side of 10 meters, the square field has a side of 10 meters all around. So every side is 10 meter, and he covers the entire boundary of a square field in 40 seconds, right? That is what is given. Now what is the magnitude of displacement? Now these two terms, let us have a brief understanding of this. We know what is displacement. Displacement is the shortest distance, right? So displacement is shortest distance between what? Between initial and the final position, right? So what will be the magnitude of displacement? Now what is magnitude? Magnitude means how much of displacement. So in this question he is asking how much will be the displacement. So when we say how much, it is actually a magnitude, right? So how much is the magnitude? So it is a way of asking what is the displacement of a farmer at the end of 2 minutes and 40 seconds. So we'll go ahead with now. A farmer, right, will be able to move along the boundary of a square field of 10 meters in how much? 40 seconds. So one round, 40 seconds. So suppose if he starts moving, he completes one round and each side of 10, and he will be covering 40 meters in 40 seconds. And why 40 meters? All you have to add this, each side is 40 meters, right? Now we have to find out at the end of 2 minutes and 20 seconds how much displacement there will be. So please keep in the mind, displacement is the shortest distance between initial position and the final position. Okay. Now what do you mean by 2 minutes 20 seconds? Can we convert 2 minutes 20 seconds in seconds? Because we know it becomes very easy that in 40 meters he covers 40 seconds, right? It's one round. Okay. Now 2 minutes 20 seconds is equal to 2 minutes 60 plus 60 plus 20. So 120 plus 20 is equal to 140 seconds. Right. Now we'll go ahead now. In 40 meters he covers, in 40 seconds he covers 40 meters. Right. Now for the second round, right, that is in 80 seconds. He will be covering 80 meters, and again he is back here. In the first round he covers all the boundary, he comes back here, and that is 40 seconds. In the second round, right, in the second round he goes here, again he covers entire thing, and that takes 80 seconds for him, and he covers 80 meters. So now how much of time is over? 80 seconds, right? Now again next round. Now if he goes for a next round here, so what happens? 120 meter he will be covering in how much of second? 40 plus 40 plus 40. And why 40 plus 40 plus 40? Each round he takes 40 seconds, right? I'm going little ahead now. So try to understand. If you have any problem in between, you can comment in the comment box, or pause the video and go back and again start the video and try to understand it. So 40 meters in 40 seconds, and this is one round over. First round is over, second round is over, and this the third round is over. Now how much of time is over? 120 seconds over. Now what is asked? We want to know not in 120 seconds, in 140 seconds. So 20 seconds again he has to cover. But at the end of 120 seconds, where is his position? Again back here. First round he started from here, it's the initial position. And then he has come back here. Second round he goes again for another 40 meters, he comes back here. Third round again he goes for another 40 meters, he comes back here. So 120 meters over and 120 seconds over. Now again 20 more seconds left. 2 minutes over now. And for 20 more seconds, you can even now easily tell me, if he covers one complete round in 40 seconds, half of this round he will be covering only these borders, and so another 20 seconds he will be moving, you know, where he will come somewhere here. So he starts moving, he will come somewhere here. Right. So now at this point when he covers, he will be covering 140 meters in 140 seconds. Right. And what does 140 second mean? 140 second means 2 minutes 20 seconds. Right. And if that is the case, what is the displacement, or what is the magnitude of the displacement? So where was he earlier? He was here. And what is the displacement? The shortest distance between initial position and the final position. Okay. And so what is the shortest distance? You have to draw a diagonal here from here to here, and that becomes shortest distance. We know that displacement is the shortest distance. So this line is the shortest distance. And now we can easily go, if we can consider this as a triangle ABC, right? And according to the Pythagoras theorem, we can write that AC square, this is AC square is equal to AB square plus BC square. Now substituting all the values, AB square is equal to 10 square, because AB equals 10 plus again 10 square. So AC square will become 10 square is 100, and again plus 100. So it becomes AC square is 200. Now you should not keep it like this. You have to find out what is AC equals. We don't want AC square. What is AC equals? AC is equal to, you know, square root of 200. Again, I recommend you not to keep your answer in this way. Now square root of 200 can be written as square root of 100 into 2, right? And we know that square root of 100 is 10. So we can take out the 10 outside. So when you take this 10 outside, the final answer becomes 10 root 2. So what is that 10 root 2? 10 root 2 is AC. Right? But now you have to put that in a proper units. So 10 root 2 meters. So finally you have to write magnitude of displacement of the former at the end of 2 minutes 20 seconds is how much? 10 root 2 meters. Never to forget these units. I hope you understood this problem. Now we'll go ahead with the next problem. A car travels first 15 km at the uniform speed of 30 km per hour. This question we have already discussed, and I have asked in the previous video to complete this question on your own. I had given you some hints on this, but however we will try to solve this. The car travels the first 15 kilometers in a uniform speed. And what is uniform speed? It's a constant speed, right? Speed doesn't change. So every second for the first 15 kilometer, it is 30 km per hour. Next 75 km at the uniform speed, again the constant speed. of 50 km per hour and the last 10 km in the uniform speed of 20 km per hour. So calculate the average speed of the entire train journey. So let us try to visualize this. A car travels first 15 kilometers, right? So this is a first 15 kilometers. He has covered the distance of 15 kilometers and how much his speed is? 30 km per hour. Okay, and then he moves. He doesn't stop there. He moves and he moves for next 75 kilometers. Next 75 kilometers, his speed was slightly more, 50 km per hour, right? And he continues his journey and he finishes his journey for next 10 kilometer and the speed is 20 km per hour. So we have three parts here. This is one, next, and this is the third. So try to again understand this problem. He has a different speed between three different time intervals, right? If this is the case, what is the average speed? Now generally, what is the speed now? Speed is equal to distance divided by, right in short, and the time taken. Okay, now average speed is, please recall, average speed is again the total distance covered. How much is the total distance covered from here to here and somewhat from here, and total time taken. And we know the total distance. How much is the total distance? 15 kilometer plus 75 kilometer plus 10 kilometer divided by total time taken. And now we have the speed, not the time, right? We have the speed at different intervals of time. So our time is not given here. Average speed we have to find. So how to find time, right? So let us take one by one time interval here. So first 15 kilometer we shall see now. This is the first 15 kilometer and we know the speed is equal to distance divided by time taken. Now cross multiplication of this. So time taken will go here and speed will come here. Therefore time will become distance covered by speed. So we have a distance as well as speed. So by using these two we shall find out time here, right? So straightway apply the equation. Time is equal to distance covered by speed, and in our case a distance is 15 divided by 30 here, right? And 15 by 30 hours, right? We'll go a little fast now. We'll go for this particular section of 75 kilometers. Again, in place of this 15 we have 75 divided by 50 km per hour is the speed, and that is the time. That is the time, 75 by 50 hours. Now the last distance, 10 kilometers. Okay, again apply the same formula. To find the time we need to have distance divided by speed, and the distance here it is 10 by 20, speed is 20, so it is 10 by 20 hours. So please remember that I am expressing this in hours because we are given with the speed kilometer per hour, right? Now we have to have a total time, right? And how to find the total time? You have to add all these together. So 15 by 30 is 1 by 2 hour. 75 by 50 is, 25 2s are 25 3s are. So it becomes 3 by 2 and this becomes 1 by 2 hours. So all that we have to add. The total time can be equal to 1 by 2 plus 3 by 2 plus 1 by 2. So since denominator is same, we can straightway go for 3 plus 1 is equal to 5 by 2 hours, right? So we will come back to this now. So our average speed is equal to 100. This total becomes 100, that is 15 plus 75 plus 10, right? So 100 divided by 5 by 2 hours, right? Now remember that 100 divided by 5 by 2 hour will becomes 100 into 2 by 5, simple mathematics, right? So that 2 will go here and that becomes 100 into 2 by 5. So that 100 into 2 by 5 is a 200 by 5. So 5 fours are, it's 40. So answer will be 40 kilometer per hour. That is the answer. So what is to be remembered here is the formula, that is average speed is a total distance covered divided by total time taken. At no situation you should take the average of this. Generally boys know, they think of taking straight away the average of this speed. So what they do, 30 plus 50 plus 20 divided by 3, and they'll write the answer. That is a wrong answer. You will not get mark for that. It's the wrong way of calculation. Okay, and that's why what you have to find, you have to find the total time taken, total distance covered, and find out what is the answer. I hope you have understood it. You have to take down this problem, solve it properly on your notebook, right? And also the earlier problem. We'll go for the third problem here. Now, what is that third? The distance between Delhi and Agra is 200 kilometer. So let us have a bit of a visualization. Delhi and Agra is 200 kilometer. A train travels first 100 kilometer, somewhere here first 100 kilometer. A train travels in the speed of 50 kilometer per hour, right? And the average speed, here average speed is given 70 kilometer per hour. The total average is 70 kilometer per hour from here to here, from here to here, from here to here. Delhi to Agra, it is 70 kilometer per hour. To get this average, how much speed he should have in the next 100 kilometer? So how much speed here you should have? So it's a slight change of the same problem which we have already discussed. Problem number 2, right? In the previous problem we had these speed is given and we had to find out average speed. Now average speed is given, we should find out what is the speed, and we already know that the average speed formula is total distance covered by total time taken, right? And total distance covered is given already, and average speed is also given. So straightway you can take 200 kilometer is the what total distance covered, and what is the average speed? 70 kilometer per hour. And what is the speed here? What should be the speed of the train to get the average speed 70 kilometer per hour, right? So this is almost like a same type, but you need to do bit different calculation here. Again we have to find the total time here. Now finding total time here in the first case of the problem is very simple, because distance and speed is given. Like in the previous way, we can simply find out by using the formula, time here. So can we find out the time here? What is the time here from here to here? So we shall call that time as time 1. Okay, this is time 1. So by mistake it has come to time 2. So we'll find out time 1. So how to find out? For the first kilometers, you have to have a formula. T1 is equal to distance covered by the time. So please remember this, since speed is distance by time, so time is distance by speed. So it is very simple now. Distance is given and speed is given. You can simply go for 100 divided by 50 and it becomes 2 hours. So what is the time? Time is 2 hours. Okay, now first case is over. Second case. Now here it's very important, and there is a tendency of we committing a mathematical error in finding this. Okay, and that's why you have to be a little bit alert. So we have already taken first 100 kilometer time. Now we'll go for the second 100 kilometer time, and then we will add and find out what is the time here, right? We will get the equation now. So T2 is equal to, right, distance covered by time, and distance covered by distance covered by speed, and here the speed is not given. So let us consider speed as x. In the previous case speed was given, right? And distance was also given. So speed and distance was given. It was very easy for us, and we got a numerical 2 hours as time. Now in this case speed is not given, but this speed we can consider as x. So therefore 100 is the distance from here to here, 100 is the distance. That's very easy. So divided by the speed is x. So we'll keep this 100 divided by x as it is. Right. Now we will add this T1 plus T2. So T1 plus T2 is equal to, right, 2 hours plus 100 by x hours. So 2 hours plus 100 by x hours. Now if you solve this mass, that will be equal to, the LCM will be x, okay, and it becomes 2x plus 100 divided by hour. So we have taken a LCM here. You see, you take a LCM here and it becomes 2x plus 100 hours, right? So we have made this a single quantity now. Now this is the total time. So what I do is, I will take this complete 2x plus 100 by x and straightway put in this total time. Right, we have already this 70 kilometer per hour. So this is the T1 plus T2 we have to put here in total time taken. So what equation we'll get? 70 is equal to 200 divided by total time, and that is 2x by 100 by x. 2x by 100 by x. Right? Now 70 is equal to 2x by 200 by 200x divided by 2x by 100. So how it has come? So you see, 200 divided by 2x plus 100 by x. 2x plus 100 by x can be written as 200 into x by 2x plus 100, right? This becomes reverse, reciprocal of this. So it becomes 200x, that is 200x divided by 2x plus 100, right? So our equation becomes 70 is equal to 200x plus 2x plus 100. So when you do a cross multiplication, it becomes 70 into 2x plus 100 is equal to 200x. Now again solve this equation. 70 into 2x, so 140x. 70 into 100, 7000. So we have expanded this, is equal to 200x. Right. Now what I'll do, 200x I'll keep here only, and this x I'll shift it here, this side. So both of similar quantities will come one side. But this becomes minus. So it becomes 200x minus 140x. So this becomes minus, and what left here is 700. Right. Therefore 700x, now you can subtract 200x, it becomes 140x out of 200x, so it becomes 60x. And therefore what is the value of x? X is equal to, I'll take here, x 60x is equal to 7,000. So x is equal to 7,000 divided by 60. Please look at it. 60x is equal to 7,000. X is equal to 7,000 divided by 60, and that amounts to, you can do a rough calculation, 116.6, and express properly in kilometer per hour, because our all units we have used in kilometers as well as hours. So the answer x is equal to 116.6 kilometer per hour. And what is x? X is the speed, right? Please go through all the 3 questions carefully. These are most expected questions, and do this homework 2-3 times and finally write it on your homework notebook. See you again in the next video. Thank you.